Okay, so far we've looked at problems where the order mattered. However, we're going to look at sometimes at problems where we want to select a few objects from a group and the order doesn't matter. So for example, if someone is choosing 3 people out of 8 for a team, in those situations, we're dealing with what's called a combination. So let's define that. When our objects are chosen from n distinct objects without regard to order, we set the objects of our objects. We call the set of our objects a combination of n objects taken r at a time. This symbol, capital C parentheses n comma r, or subscript n capital C subscript r, denotes the number of combinations of n objects taken r at a time. The formal formula for this is n factorial over the quantity n minus r factorial times r factorial. And you're going to see combinations. Another way to notate this is using this where you have n choose r. So it's big parentheses, you put the n on the top and the r below the n. Now, we can also do this using ding, 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 Desmos, which you can kind of see I've got an example of that down here, which I'll go over. So if students are allowed to choose 9 out of 11 problems to work for extra credit on an exam, how many ways can this be done? So first I need to think about, is this a permutation or a combination, or am I just going to use the fundamental counting principle? So students are allowed to choose 9 out of 11 problems. So there's distinct objects. So there's 11 different objects. Obviously there's no repeating because you can't do the same problem 9 times. I mean, that would be cool if you could, but. And let's see, does the order that I choose the 9 problems matter? No, the order does not matter. And that's when you know you're using a combination and not a permutation. All right, so if I set this up, this would be using a combination, our n value. So there's 11 problems they're choosing from, and they're picking 9 out of those. So our r is 9. And again, in Desmos, they have this great function. And when you click the function calculator, you click this NCR, that's a combination, and it'll actually evaluate it for you. And so we get 55. You could have also done this the long way. So I just want to show you how to do it by hand. So the combination of 11 choose 9 is going to be 11 factorial over 11 minus 9 factorial times 9 factorial. Okay, we can simplify this out. 11 factorial is the same as 11 times 10 times 9 factorial, because we'd have 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. The reason I'm writing it like that is so that these 9 factorials will cancel. And then 11 minus 9 is 2 factorial. All right, so those 9s now are going to cancel out, and I'm left with 11 times 10, which is 110, over 2 factorial, which is 2 times 1, which leaves me with 55. Okay, let's look at another example. In how many ways can Ashley choose 4 out of 11 different canned goods to donate to charity? So this, again, is a combination because you can't repeat. So there's no repeats. And the order doesn't matter. She's just going to be given the 4 cans there. It doesn't matter which order she chose them to give to charity. So that's how we know that we're dealing with a combination. So in this situation, our n is 11 since there are 11 cans she can choose from, and our r value is 4. She's choosing 4 out of those 11. So I'm dealing with a combination with 11 choose 4. Putting that into Desmos using that NCR function gives us 330 different options for her to choose from. And last, a group of 4 students is to be chosen from a 35-member class to represent the class on the student council. How many ways can this be done? So let's first figure out if this is a permutation or a combination or neither. So let's see, we're choosing 30 out of 35 people, we're choosing 4. Are we repeating people? No, there's no repetition, there's no repeats. That tells us we're a permutation or a combination. Does the order matter that these 4 students are chosen? And in this case, no, because No matter what, if you're chosen, you're on the student council. It doesn't tell you what position you are on the student council. So the order doesn't matter that they're chosen. They're all going to be lumped into the student council. So because the order doesn't matter, we're dealing with a combination. So this is a combination, Rn. So how many different options do we have to choose from? 35. How many people are we choosing out of that? 4. So our N is 35 and our R is 4. Using Desmos gives 52,360 different ways that this can be done.